Welcome back to the Solutions Manual. In this video, we will solve the problem 3-4 from RC Hibbeler Engineering Statics 15th edition. According to this problem, if the forces are concurrent at point O, we have to determine the magnitudes of force F and T for equilibrium, and we have to consider theta as 90 degrees. Now to solve this problem, first of all, I have to resolve the forces along the x and the y axis. So for force F, I have a vertical component and the horizontal component. Similarly, for the force T, I have a vertical component and the horizontal component. Let's consider this angle as alpha and let's call this angle as beta. So for alpha, we can consider this 3, 4, 5 triangle. And if I draw it separately, then it would look something like this. So this is 5, this is 3, and this is 4. So alpha is basically this angle, which is the corresponding angle. So for alpha, we can use the trigonometric ratio of tan. So tan alpha is equals to opposite, which is 3, over the adjacent, which is 4. So alpha comes out to be 36.87 degrees. And now we have to find the angle beta. And why do we have to find the angle beta? Because if this angle is beta, it means that angle is also beta. Because they are alternate angles, so they are same. So we know that theta is equals to alpha plus beta. And theta is 90 degrees. So angle beta comes out to be 90 degrees minus the angle alpha, which is 36.87 degrees. So angle beta is 53.13 degrees. Now let's label the force components. So the vertical component of force F is F sin alpha, and the horizontal component is F cos alpha. The vertical component of force T is T sin beta, and the horizontal component is T cos beta. So far we have resolved the forces into their components. Now we can apply our equations of equilibrium. So my first equation is summation of forces in x direction equals to 0. I am considering right hand side as positive. So we have T cos beta, and beta is 53.13 degrees, minus F cos alpha, and alpha is 36.87 degrees, equals to 0. So upon simplification, we have 0.60 minus 0.8 F equals to 0. Let's call this equation 1. Now in this equation, we have two unknowns and we have a single equation. So we have to form another equation. So for my second equation, I have summation of forces in y direction equals to 0. I am considering up direction as positive. So we have 9 kilonewtons minus F sin alpha, and alpha is 36.87 degrees, minus T sin beta, and beta is 53.13 degrees, equals to 0. So upon simplification, we have 9 minus 0.6 F minus 0.8 T equals to 0. Let's call this equation 2. So now we have two equations and two unknowns, so we can simultaneously solve them. You can use any of the methods to solve the simultaneous equations. I'm going to use the method of substitution. So I'm going to consider equation 1. Consider equation 1, this equation, and I am going to make F the subject of my equation. So we have 0.60 minus 0.8F equals to 0. F is equals to 0.60 upon 0.8, and upon further simplification, f is equals to 0.75t. Let's call this equation 3. Now I am going to substitute equation 3 in equation 2 in this equation. So equation 2 becomes so we have 9 minus 0.6f, and in the place of f I am going to substitute the equation 3. So 0.75t minus 0.8t equals to 0. So we have 9 minus 0.45t minus 0.8t equals to 0. So upon further simplification, t comes out to be 7.2 kilonewtons. So this is our first answer. Now to find the value of f, we can substitute the value of t into the equation 3. The equation 3 becomes f is equals to 0.75t and t is 7.2 kilonewtons. So f comes out to be 5.4 kilonewton. So this is our second answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.